Hello friends, welcome to our YouTube learning channel Accurate ASME ISO. This video is going to explain about the linear feature sizes according to the international standard ISO 14405-1 and ASME Y14.5. Any of the sizes produced on the real part are not the actual mating sizes to its counter feature size, which are the mating parts in the assembly. So which are those sizes which are significant for its counterpart? So in this video we are going to discuss all the sizes types, local sizes as well as the global sizes. So let us start this video for complete understanding of the feature sizes, and also please do not forget to subscribe this educational channel. For the designers designing the product or the part with their shapes and the sizes, and after that producing it on a mechanical engineering drawing, the shapes they drawn are without any of the deviation for the size and the forms. It means all the features they produced on the drawing are the nominal. But in real world it is impossible because of economic and some other reasons. Therefore certain amount of deviations are already allowed by the designers. While making the assembly, functional mating or fit is very important, and for that verification of the produced part is a very challenging if certain rules are not followed. So in this video we would discuss certain the principles, definitions and certain rules according to the international gd&t standard. ISO 14405 establishes the default specification operator as well as the very special specification operators for the linear sizes for feature of size like the cylinder, sphere, torus, circle, two parallel opposite planes or two parallel opposite straight lines. Here two parallel opposite planes are slots or the external square taps. In this drawing, shaft size is 34 with 0 and minus 0.05 tolerance. Similarly, the hole is specified with diameter size of 10 and tolerance plus minus 0.25. In these cases, no special size specification operator produced. Therefore, it becomes a default Gaussian base fit or least square operator. In the verification, generally average size is measured in such conditions. ISO 14405 consists of total 3 parts. Part 1 deals with the linear sizes. The part 2 deals with dimensions other than the linear sizes, and finally the part 3 deals with angular sizes, angles and their tolerances. In the part 1, following linear sizes like local size and global sizes are discussed. The local sizes are 2-point size, spherical size, section size and portion size, whereas in global sizes, direct global linear size, least square size, maximum inscribed size, minimum circumscribed size, minimax size and indirect global linear sizes are discussed. In the standard, to represent on the drawing, the symbols for the feature of sizes are given. For the local sizes, if 2-point size is to represent on the drawing, the symbol LP is shown. It is a modifier. So similarly for the spherical size, LS, and for the section size it is ACS. ACS, it is a short form of any cross section. Then in case of the global sizes, there are important sizes are least square size. The symbolic representation is G or GG. Then maximum inscribed size is X or GX, and minimum circumscribed size is GN or EN. In this given drawing, the size of the cylinder specified is 34. On plus side no tolerance, and at lower the tolerance is minus 0.05. Now let us think, after manufacturing, a certain size and shape of this part is produced. For example, it is as shown in the figure. Surely it is not exactly the same as in the drawing shown for its size and the shape. Suppose we do verify the size of the part against the drawing specifications given. Maybe at this height, or here, or at this location. All these sizes are not same as we see, but not necessarily out of tolerance. All sizes are called actual local sizes or the 2-point sizes. If we want to know the size which will fit to know that 2-point local size must be measured at perpendicular to the axis of the cylinder. In case of the section size also, a section is cut at any location but should be perpendicular to the axis of the feature. Portion size is measured at the specified length and location of the feature. Now let us discuss global sizes. In this given drawing, the hole position is specified with respect to datums C, A and B. Also, we note that the symbol G is given here. This symbol represented that the position of hole is calculated when the hole is measured with calculation of least square method. Size, location of this hole would be with the best fit computation of the method. Least square fitting size is generally an average size of the points measured. In this figure, red colored profile shown is a actual hole boundary. The blue colored hole or the circle is computed with least square fitting method, which is called a Gaussian best fit method. This size is calculated as an average size of the feature. In this given drawing, the shaft position is specified with respect to the datum C, A and B. Also we note that the symbol N is applied. This symbol represented that the position of shaft, that is the axis of the shaft, is calculated when the shaft diameter is measured with the calculation method of minimum circumscribed circle. Minimum circumscribed circle is drawn through the points which are most outer points, or we can say that all points are inside or on the circumference of the circumscribed circle. In this drawing, red colored profile is an actual shaft and the blue colored is a minimum circumscribed circle feature. This drawing requirement is positioning of a hole with respect to datums C, A and B. Also we note that the symbol X is applied here. This symbol represented that the position of a hole axis is calculated when the hole diameter is measured with the maximum inscribed computation method. The size and the location would be for maximum inscribed circle. Maximum inscribed circle is constructed through the points which are most inner points, or we can say that all the points are outside or on the circumference of the maximum inscribed circle. Red colored circle here is an actual circle, whereas blue colored is a maximum inscribed circle feature. Here is a summary representation of global and calculated size. This is a least square size. As we know, the least square size is nothing but the average size calculated from the points. Then minimum circumscribed size. Minimum circumscribed, that means the most outer points are taken for the calculations, that is the envelope size calculated. Exactly opposite is the maximum inscribed size. In this maximum inscribed size, we can see that all the points are outside of the maximum inscribed size. Then Chebyshev size. Chebyshev size is a very special kind of the calculation method or computation method to fit the feature, and mostly it is used for the making of the form tolerance measurement. Difference between minimum circumscribed and maximum inscribed circle. So this side you see it is a minimum outscribed circle and here is maximum inscribed circle. So this refers to the smallest possible circle that can completely circumscribe or surrounded a given locus of points. In simpler terms, it is smallest circle that can be drawn around the locus of the points. Minimum outscribed circle is used for the external features like shaft or outside features, size features. it is always greater than least square circle. In case of the maximum inscribed circle, this refers to the largest possible circle that can be inscribed within a given locus of points. In other words, it is the largest circle that can fit inside the locus of points such that the entire circle is inside the boundaries of the profile. Maximum inscribed circle is used for the internal features like holes. Let us discuss now the difference between least square size and the Chebyshev size. Least square size. The least squares feet of a geometry, also known as the method of least squares fitting, is a technique used in mathematics to find the best fitting geometry to a set of data points measured or collected. It is the average or mean calculation method. When no specifications are provided on the drawing, then default method could be the best fit or a least square fitting method as shown. In case of Chebyshev size, the median geometry which is extracted from the real geometry is known as the Chebyshev fitting. In case of circle or cylinder, all extracted points are on or inside of the two circles or cylinders that are concentric to the Chebyshev circle or cylinder and have a minimum distance between them, that is radial distance, and sometimes it is also called as a minimum zone, and that is the reason it is also known as a minimum zone method. The reason is also known as minimum zone method. Chebyshev fitting method is used when form tolerances are required to verify. Here is a combined or summarized symbolic representations of the size specifications. So the geometries like the straight line, plane, circle, cylinder, cone, torus and slots, all are the size features. Then for which feature, for example, let us take the plane. For the plane, is Gaussian fitting is allowed? Yes. But for the plane, there is cannot be the maximum or minimum type of the calculation available, but tangent calculation is available. Similarly, for the circle cylinders, we can say that the all type of the calculations is available except the tangent. So this table shows us the what type of the feature is and what type of the modifier for the size and the calculations are allowed.
Hope that you have liked this video with very easy and simple explanations. You can comment how do you see this initiative and suggest more on upcoming videos. Also, we are pleased to conduct training programs at your locations in factories. We offer ASME Germany, an international CMM certification course, Basic of gd&t, Advanced gd&t, Stack up tolerances, Surface finish, MSA and other quality tools. For further details, please contact us. And I'm sure you will encourage the initiative of training through YouTube, by subscribing a channel. Accurate, ASME, ISO. Thank you and have a good day.
Hello, myself Sankalp Bhaskar. I am working in BSTC as a supplier quality manager, and I especially thank you Bhumin sir who came here for to give the training on applied and advanced gd&t. So once again I thank you to them, and the experience of this training, there was 2 days training, and it was very wonderful, and we gained a lot of information with this training. Previously we know how to check, but how to apply those gd&t technologies or symbols, or how to measure that we are not comfortable, but now we understand how to apply those gd&t symbols and how we measure. So now we confident that we can, what are the parts we are measuring, we will get the accurate results to our team, and with that we will correct those parts in good with limited times, and we will achieve the quality of the parts very accurately in very less time. So thank you once again to Momin sir for giving their guidance, and I hope they will continuously support to us in case of any issues we observe. So once again, thank you.